Hey, how you doing? My name is Steven J. Tomobi, and this is my Gridworld project for the AI class. Essentially, what I have is I have implemented a GUI for sarsa lambda, and essentially the training data. I'll just go walk through my code briefly to explain what it does, just to give you an understanding of how I approached solving this. Because it was a fun project to work on, I'll be honest. But so here we go. So I have my epsilon set at 90. I have my epsilon set at 90, and I have the decay set of 0.001. And the reason why I do this is because I have a max epoch count of 600,000. That is, it runs 600,000 times. And the idea is that, well, it decays every 1,000th epoch by 1. So after 600,000, that's 60 epochs, so 60 decays. We have a epsilon of 30 at the end of the training set. So essentially, I'm just going to walk through this code to explain what it does really quick. But what I have is I have this train here, and essentially what it does is we say, well, while we're still, running, while the epoch count is less than the max epoch count, and while we're running, there's no terminal state. Essentially, we query the queue table to get the cell at the player's position, because the player is placed randomly on the board initially. And we have a decision factor to determine whether we explore or we exploit. If we explore, and then we query for the player's current state and the action that goes with the current state, as well as the direction that goes with that action, so up, down, left, or right. And essentially, the next state is just whatever the player's next state is based on the action that they were supposed to take. And this is also the action that occurs with that state is also obtained from using the epsilon greedy approach, which is just using the decision factor to see if the value to see if we explore or exploit if the value is less than equal to epsilon, or if it's greater than epsilon. So I ran this and I trained it for a while, and when it was done, I made it write to a file, because it took a while at first, honestly. Essentially, I made it write to a file, and this file has the weights corresponding to each cell. So each cell has 4 weights, and we have 400 cells because it's a 20 by 20 grid. And I wrote a GUI for it just to show that the player has actually learned. So I'm just going to run it to display what I currently have. Alright, so right here we have the world, and essentially we have the buffer zone, which is right here. And I have this nice utility that basically displays the position on the board for me, so it can query cells directly based on the mouse position. I did that just in case I wanted to add a click, so you could click a cell and place the player on the board. But I have this going on here, so if you click on the cell, it tells you the weights associated with the cell, and it tells you the cell type. So you can see the weights for going up, down, left, or right. You can see the goal state. Those numbers don't really matter for the goal state. For obstacles, we have the weights there as well, and for the buffer, there are just no weights. So essentially, you can place the player anywhere in the world randomly. Ideally, not on an obstacle, but you can place the player on an empty cell, and you can set the player on the board. So the player is set, and we can start. And it tries to find the goal state. So put it somewhere random. It doesn't really matter. Set a player, and we start it. Goal state. And there's a delay slider here that can delay the amount of frames that the player renders at, so you can actually view the animation in slow motion if you wanted to. I'm not going to run that right now, but if you want to play with that, you can play with that as well. Well, this is my Gridworld project, sarsa lambda. It was a fun project. Thank you for watching.